Good morning, everyone, and welcome to this lecture. This is lecture number 1, and we are dealing in wave optics. We'll start this topic on wave optics. Now, what do you mean by wave optics? Anyone, any idea? What is wave optics? What do you mean by wave optics? We first start with the definition of light. What do you mean by light? What is light? So, light, the physical cause with the help of which our eyes experience the sensation of vision. That is what we call as light. This light excites our retina and we can see things around us. That is light. I hope you know it. You may not have to write it, just have to understand what is light. Now, whenever we talk about the properties of light, what are the properties of light that you are aware of? Are you aware of any property of light?
It travels with speed of 3 into 10 power 8 meters per second.
So, when we talk about the properties of light, there are a few properties of light that you must remember. We have seen in the chapter on electromagnetic waves that light is an electromagnetic wave, and as soon as we know that light is a EM wave, light, any type of light is an EM wave. It does not require any material medium. It can travel through vacuum. Its velocity is constant in all inertial frames, and the velocity is equal to 3 into 10 raised to the power 8 meter per second. If we are talking about visible light, the visible range of light is from 4,000 to 8,000 Armstrong unit. You must know these facts. They are asking questions based on facts. The energy of light or a photon of light, we have seen that theory that will be in electron volts. Light always travels in a straight line. I hope you remember this.
Yes, sir.
Okay, then whenever we talk about light, light can exhibit phenomena like interference, diffraction, polarization, double refraction. It can emit electrons from metal surface. We have seen this photoelectric effect. Do we remember this photoelectric effect?
Yes, sir.
Okay, these are the properties of light. Here we are talking about visible light in particular, but apart from the wavelength thing, everything is common, whether it is visible light or ultraviolet light or infrared light or X-ray or whatever. I'll give you a minute to note this down. Moving ahead with the other properties, it produces thermal effect. When light falls on some surface, it will exert pressure and it will heat up the surface. In different mediums, the speed of light is different, and we will get to know about something known as refractive index when we talk about refraction. Now, whenever we talk about light, we can imagine the light may be propagating by two processes. The first process is it carries particles, and these particles carry energy from one point to other. This is known as the particle theory. Do we understand this? Light may travel as a particle. We have seen photons. The second way suggests that it moves in the form of a disturbance. Whenever we talk about disturbance, any disturbance means that it is a wave theory. Do we understand this? So light has dual nature. It may behave as particle, it may behave as a wave. We know this, yes or no?
Yes, sir.
There are 5 different theories of light. It describe how light behaves. Newton's theory, Huygens wave theory, Maxwell's electromagnetic theory, Planck's or Einstein's quantum theory, and de Broglie dual nature of light. Just note them down and I'll give you a table which tells us how different theories of light are different from each other or same compared to each other. And these are the different theories put together in one table. Newton's corpuscular theory is similar to Einstein's quantum theory or Huygens quantum theory, where they imagine light to be based on tiny particles. In Einstein's quantum theory or Planck's quantum theory, they call it photon or quanta. Here, Newton called them corpuscles. Then we have Huygens wave theory, which we are going to study now, in which the light travels as a wave. In EM theory, it is an electromagnetic wave, and we have seen the speed of light is constant. Then we have de Broglie's wavelength. Remember de Broglie wavelength, where he says that light has got a dual nature. It can behave as a wave or a particle. Wave nature of light dominates when light interacts with light. The particle nature dominates when light interacts with matter. That's a very important aspect that de Broglie gave us. So these are the 5 theories. You can note them down fast. Then these are the different phenomena in the left column, and then the 5 different theories of light. Which theory explains which phenomena? You will notice that whatever is explained by the Newton theory is same as quantum theory because it is derived from that. So whatever you see in the Newton corpuscular theory, the same thing you will find in Einstein's quantum theory, the same phenomena explained. Similarly, the Huygens wave theory or the EM wave theory both consider light as wave. So you can see all these phenomena which are explained by the wave theory will also be explained by the EM wave theory. Then comes the hero of them all, and the hero of them all is the dual theory, which explains every possible uh, phenomena that we can see. Another point to note here is whether it is rectilinear, straight line propagation, reflection, or refraction. These are explained by all the 5 theories. Do we see this?
Yes, sir.
The other thing to note is the photoelectric effect, which is particle theory, is only explained by the quantum theory. Do we see this?
Yes, sir.
It's not even explained by the corpuscular theory. Then the rest of them, dispersion, interference, diffraction, polarization, double refraction, Doppler's effect, they are only explained by the wave theory of light, which is what we are going to experience. Do we understand this?
Yes, sir.
I'll give you a minute to note it down. Then we come to the wave theory, but before going on to wave theory, we must understand a term which is going to come a lot of time here, is the wavefront. What do you mean by a wavefront? Now, this wavefront is a phenomena which was explained by Huygens wave theory, or it was given by Huygens wave theory. Therefore, the first point that you must remember about a wavefront is that it was suggested or given by Huygens in his wave theory. Now, what is a wavefront? It is a locus of all particles in a medium which is vibrating in the same phase. If you have particles, if you remember the concept of wave is just a disturbance. Whenever wave propagates in a medium, particles oscillate. If you take any number of particles which are oscillating in the same phase and you find the locus of those points, that would be known as a wave front. The next thing that you must remember about a wave front is that the direction of propagation of light, the direction of propagation of light, the direction of propagation of light is always perpendicular to the wavefront. Do we understand this?
Yes, sir.
The direction of propagation of light is perpendicular to the wavefront. Now, talking about the types of wavefront we will encounter, we may encounter three types of wavefronts. We may encounter three types of wavefronts. What has happened here? We may encounter three types of wavefronts. Any idea what are the three types of wavefronts that we may encounter? The three types of wavefronts that we may encounter, the first one are spherical wavefronts. These spherical wavefronts are created by a point source of light. Here you can see there is a point source of light, and this point source of light creates spherical wavefronts. If we draw a sphere with the center as the point source, all the points on that sphere would be in the same phase, and therefore the wavefront created by a point source would be spherical. If you have a line source of light, a source which is like a line, do you see this line source here? This is a line source. A line source of light will create cylindrical wavefronts. If you draw a cylinder with the line as the axis, all the points on that cylindrical curved surface will be in the same phase. Do we understand this?
Yes, sir.
If you have light rays which are coming from a very far distance, if these light rays are parallel to each other, then the wavefronts that they will create would be plane wavefronts. Do we see this?
Yes, sir.
As soon as you see these three diagrams, a point source creating spherical, a line source creating cylindrical, and an source which is very far away, parallel rays of light, you will have plane wavefronts. Looking at these 2 points, wavefront and the direction of propagation of light rays and the shape of the wavefront, does it remind you of something that we have done sometimes before? Looking at the shape of this wavefront, point source, spherical, line source, cylindrical, parallel lines, perpendicular wavefronts, does it remind you of something that we have done previously? The answer either is says yes or a no. Don't take so much time to say a yes or a no. Does it remind you of anything? Spherical, point source, spherical, line source, cylindrical. Does it remind you of anything? Either it reminds you or it does not remind you. Does it remind you of anything?
Yes, sir.
What?
Uh, Electric field.
Electric fields. Well done. It reminds you of electric field. So you can imagine this direction of light ray. The direction of propagation of light ray is something like electric field, which was a vector. Now, if this was electric field, what we can think of this wavefront as? This wavefront can be thought of as equipotential surface. And if you remember equipotential surface where points had the same potential and electric field was perpendicular to the equipotential surface, similar thing is happening here. The direction of propagation of light ray can be taken as electric field and the wavefront can be taken as equipotential surface. They refer to the same sort of a principle. Do we understand this?
Yes, sir.
I'll give you a minute to note this down. You can also note down that same thing, tabular form, spherical wavefront created by a point source. The amplitude is inversely proportional to the distance and the intensity is inversely proportional to distance square. I have told you this thing many times starting from the chapter on waves, and I'll keep on telling you. For a cylindrical source of light, linear line source, the amplitude is proportional to root over distance, intensity is proportional to 1 by inversely proportional to distance. If you have planar source of light, amplitude and intensity both are constant. Everything you have written, only the extreme right hand side, the two columns, the variation of amplitude and intensity, and you can see intensity is proportional to amplitude square. Do you remember that?
Yes, sir.
So if you just remember the variation of intensity, you can find out the variation of amplitude. I'll give you a minute to note this down. Then we can note down the different characteristics of this wavefront. Remember, any question can be asked. The phase difference between any 2 points on the same wavefront would be 0 because they are in the same phase. This wavefront travel with the speed of light. A point source will give a spherical wavefront in an anisotropic. An anisotropic medium is a medium which has different properties in different directions. If the medium is anisotropic, the wavefront will travel with different velocities in different direction. Normal to the wavefront will always represent ray. Remember, you can think of this wavefront as which? You can think of this wavefront as equipotential surface. Do we understand this?
Yes, sir.
It always travels in the forward direction in the medium. So wavefront will go like this. Wavefront, the source of light is here. Wavefront will always go in the forward direction. You understand? All these are forward direction. Do we get this? Then this ray of light can be thought of as your electric field. Do we understand this?
Yes, sir.
It gives us the path of the ray. It is a line drawn at 90 degrees to the wavefront. It represents the direction in which the light is traveling. We understand this?
Yes,
I'll
sir.
give you a minute to note it down. Then we move on and see the important points of this wave theory of light. This wave theory of light was given by Huygens. Therefore, it is known as the Huygens wave theory. Everyone knows this? Yes or no? The
Yes, sir.
spelling is wrong here. It should be Huygen. It was given by Huygens and therefore it is known as the Huygens wave theory. And he imagined that there is a medium known as ether. No one is going to ask you this. Ether is a medium which is isotropic. When I mean isotropic, it is same in all dimensions. Anisotropic is different in different dimensions. The different colors of light are due to different wavelengths. The velocity of light in any medium is constant, but different medium it is different. It is valid for all types of waves. Remember, And what are the main points that he gave? The first point that he gave was the locus of all points vibrating in the same phase is known as a wavefront. We have already seen that. Yes or no?
Yes, sir.
Light travels in the form of wavefront. We have seen that. Yes or no?
Yes.
When light travels in a medium, then particles of the medium start vibrating, and therefore a disturbance is created in the medium. Yes or no? So
Yes.
when light is traveling, it is creating a disturbance. Every point on the wavefront, every point on the disturbance becomes a secondary source, and they emit secondary wavefronts. These secondary wavefronts are known as secondary wavelets. Then these secondary wavelets will emit secondary this all points will emit the secondary wavelets, and the tangent drawn to the secondary wavelets will give us the new position of the wavefront. So basically, if I am a source of light, I am creating a disturbance. At any point, if I draw locus of all points in the same phase, I will get the wavefront. Now all points on the wavefront will become new sources, and they will emit their own wavefronts, which are known as secondary wavefronts. The tangent drawn to the secondary wavefronts gives us the new position of the wavefront. Do we understand this? I will show you with the help of a diagram. Right now, just note it down and I'll explain it again. You have 2 minutes to note it down. Note it down, Aram. Now let us try to understand what was said here. You can see here a point source of light. It is emitting waves in all directions. The wave is traveling in the form of a wavefront. Do we see this?
Yes, sir.
This yellow one is the original wavefront that is there. So at some point in time, we have this yellow wavefront, which is the original wavefront. Do we see this?
Yes, sir.
Now on this original wavefront, we have different points, and I have marked 4 points. 1, 2, 3, 4. Do we see this? 4 points.
Yes, sir.
Now these 4 points become source of light, and they emit their own wavefronts. Do you see these pink wavefronts that they are emitting?
Yes,
These
sir.
pink wavefronts are known as secondary wavefronts, which is emitted by these point sources. Do we see this?
Yes, sir.
If I take the tangent, or if I take the envelope of all these secondary wavefronts, we will get the blue wavefront, which is the new position of the next wavefront. Do we understand this?
Yes, sir.
Similarly, if I take the backward envelope, the green one, it will tell us the last wavefront before the original one. Do we understand this?
Yes, sir.
Similarly, you can see here this is the yellow wavefront, the original wavefront. Do we see this?
Yes, sir.
This blue one is the new wavefront. Do we see this? Same thing.
Yes, sir.
We see this. Understand this? Huygens wave theory. Do we understand this?
Yes, sir.
And this green one is the previous wavefront. So this is how we can understand Huygens wave theory. Have you understood this?
Yes, sir.
I'll give you 2 minutes. If you want to draw it, draw it. Then you can note down what are the phenomena explained by this theory. Almost everything is explained by this theory. What is not explained is the particle thing, photoelectric effect, Compton effect, and Raman effect. It also does not explain the backward propagation of light. Rest all, it neatly explains. I'll give you a minute to note this down. Remember, any of this may come as question in your exam. Then we move on to the next and the most important heading of this chapter is known as principle of superposition. I hope you have heard this term before, and we have seen what do you mean by the principle of superposition. Do we remember this principle of superposition? Yes or no?
Yes, sir.
We had seen it in terms of electric field. If at any point there is more than one electric field, the net electric field is the vector sum of all electric field. If there is more than one force, the total force is the vector sum of all these forces. Yes or no?
Yes, sir.
Similar to this, when two or more waves simultaneously pass through a point, the disturbance of the point is given by the sum of disturbance of each wave that each wave will produce in the absence of other wave. In case of wave on string, disturbance means displacement of the particle. In case of sound waves, it means the pressure change. In case of EM waves, it means the net electric field or the net magnetic field is the vector sum. Do we understand this?
Yes,
In
sir.
most of the cases here, we will be dealing with waves, not EM waves. Therefore, we will call it as the resultant displacement. So, whether it is resultant displacement or resultant pressure or resultant electric field, the concept remains same. When two or more waves are traveling and passing through one point, the total displacement of the particle is the vector sum. This is known as the principle of what?
Superposition.
This is known as the principle of superposition of waves. Do we understand this?
Yes, sir.
I'll give you 2 minutes to note this down. As I told you before, it is valid for any types of vector. Yes or no?
Yes, sir.
Note it down. Then we can look at the graphical view of the same thing. You can see this displacement y1. Then you have the displacement due to the second wave y2. The net displacement will be y1 plus y2. If you take in terms of sine waves, the two waves are going to get added up if they are in the same phase. If they are in the opposite phase, one is like this and the other one is like this, they are still going to get added up, but then effectively they would be subtracted. Do we see this? This is the first wave.
Yes.
This is the second wave. Oh, this is the second wave. Do you see this, bacha? The
Yes, sir.
net wave would look like this. Everyone understands this?
Yes, sir.
I'll give you 2 minutes. If you want to note it down, note it down. Then we come to the next heading, and we have already done this phase difference, part difference, time difference. Do we remember this?
Yes, sir.
If you have a wave given by y is equal to a sine omega t, do you remember? This omega t will be known as the phase or the instantaneous phase of the particle. We have done it in SHM. We have done it in waves as well. Yes or no?
Yes, sir.
Then if you have two waves, my dear friends, one is y1 is equal to a1 sine omega t, the other one is y2 is equal to a2 sine omega t plus phi. We can see that in between these two waves there is a phase difference. Yes or no? No or yes?
Yes, sir.
One wave is ahead, leading, other wave is behind, lagging. We saw it in AC also. Which wave is ahead and which wave is lagging? Between y1
Y1,
and y2.
Y1 is ahead and Y2 is lagging.
To take a deep breath like this. Close your eyes. Think about it. Open your eyes. Listen to the question and then give the answer. Between y1 and y2, which wave is ahead and which wave is behind?
Y2 is ahead.
Y2 is ahead and Y1 is behind. You can also find out the path difference. I will call it as delta X. The path difference delta X would be equal to lambda by 2 pi lambda by 2 pi multiplied by the phase difference phi. You can also find out the time difference delta t by 2 pi into phase difference. I told you that in the very first class on waves that delta phi phase difference divided by 2 pi is equal to delta t time difference divided by the time period. That will be equal to delta x, the path difference divided by lambda. This is the last time we are seeing this. Please note it down very, very carefully. So let us move ahead and we can now see the superposition of two waves and we can find out the resultant intensity and resultant amplitude. I think that we have done this before, yes or no? If I have two waves, let us say given by these, x1 is a1 sine omega t, you can call it x1 or you can call it x2 or you can call it y1, and x2 is a2 sine omega t plus phi. Which is ahead and which is lagging here?
X2 is ahead and X1
X2
is
is
lagging.
ahead and x1 is lagging. They are superposing. So the resultant displacement x will be given by a1 sine omega t plus a2 sine omega t plus phi. We can write it as a is equal to a sine omega t plus phi naught, where what is your a? A is your resultant amplitude and that will be given by under root of a1 square plus a2 square plus 2 times a1 a2 cos phi, yes or no?
Yes, sir.
And this tan of this phi naught, the phase difference, will be given by a2 sin phi upon a1 plus a2 cos phi. All of us understand this?
Yes, sir.
And how we have added this? We have added this considering them as vectors. We have considered that a1 is here. We have considered that a2 is here. The angle between them is phi, and when I add these two, I will get the amplitude as capital A, and this angle would be equal to phi naught. Everyone understands this?
Yes.
Give you 2 minutes to note this down. Now, whenever we talk about amplitude here, we must also talk about the intensity, the resultant intensity. Remember, I1 will be equal to k into a1 square and I2 will be equal to k into a2 square. Do we understand this? Where k is a constant which depends on certain factors of the medium. Yes or no?
Yes.
You must remember this. We have already discussed this. We can write the resultant intensity as I1 plus I2 plus 2 times root over I1 I2 cos phi. Do we remember this in the chapter on waves?
Yes, sir.
Now remember what you need to understand here. This term that is coming here 2 times I1 I2 cos phi is known as the interference term. For non-coherent sources or incoherent sources, what is incoherent, what is coherent, we are coming to that. This term is zero. So the formula for non-coherent or incoherent sources, a very important point, for non-coherent or incoherent sources, the resultant intensity is I1 plus I2. Cos phi does not come there. Remember this, it is a very, very important point. I'll give you 2 minutes to note it down. Also, we must note here that we've already discussed this. The maximum intensity and we will see that in much details now. Maximum intensity will be given by a root over I1 plus root over I2 square, and maximum amplitude will be given by A1 plus A2. Do we remember this?
Yes, sir.
Similarly, my dear friends, the minimum intensity will be given by root over I1 minus root over I2 whole square. The minimum amplitude is given by A1 minus A2 or A2 minus A1, depending on which one is more. Note this down because you might be needing this to solve some questions.
Yes.
To solve this question, E1 is given as 3 sin omega t, E2 is given as 3 cos omega t. I'll give you 2 minutes. Did you get any answer, beta?
Yes, sir.
What answer?
5 sine omega t plus 53 degrees.
Very good. So the first wave E1 can be written as 3 sin omega t. The second wave E2 can be written as 4 times sin omega t plus pi by 2. Yes or no?
Yes, sir.
So the resultant wave E can be written as under root of A1 square plus A2 square. It will be 5. And then you find out the angle. It is going to come as 53 degrees. Yes or no? So you can write
Yes.
like this. Well done. Now let me put this question. And these are the type of questions that would come this is the type of question that you are going to see in the examination hall. S1 and S2 are two coherent sources of frequency f each. The wave equation, the angle theta 1 and theta 2 or phi and phi 1 are 0. The velocity of sound is 330 meter per second. The question is not complete and we have not seen what is constructive interference. So what I will do is we will do this question after we have understood what is constructive and what is destructive interference. We have not seen that part. So let me just put another question here. This one. Light from two sources, each of the same frequency and traveling in the same direction but with intensities in the ratio 4:1 interfere. What is the ratio of maximum to minimum intensities? These are the type of questions that are coming in the exam these days. I'll give you 2 minutes to give me the answer. Yes, beta, you got the answer?
3:1, sir.
I max by I min would be equal to, my dear friends, under root of I1 plus under root of I2 divided by under root of I1 minus under root of I2 the whole square, bacha. Do you understand this?
Yes, sir.
Whole square. If I just write it, it will look like this. You can also remember this formula: root over I1 plus I2 plus 1 divided by root over I2 I1 minus I1 by I2 minus 1 whole square. So this will be, I think, 2 plus 1 divided by 2 minus 1 whole square, and the answer that you are going to get would be. Do we get this better? No,
Yes, sir.
I got disconnected. Is that so? Let me just take it again with you. So it will be root over I1 divided by root over I2 plus 1 divided by root over I1 by root over I2 minus 1 the whole square. So that will be 9 is to 1. We got this, yes or no?
Yes, sir.
Well done. I'll give you 2 minutes to note this down. Well then, we will go ahead with this topic in the next class. In the next class, we will be seeing what do you mean by coherent and incoherent sources. I think we discussed this point in the chapter on waves also, and I told you that to get coherent sources of sound is simple, but to make coherent sources of light is not so simple. So we will see what are coherent sources. Do you know what is coherent source?
Which have same amplitude with same phase.
Yes, not same phase. Phase difference must be constant with time. So we will get back on that and we will see it in details. What do you mean by coherent sources and why coherent sources are needed? In the next class, I'll continue with this and then we'll start with the most important heading of this wave optics, which is known as interference of light and Young's double slit experiment. More than 99% of the questions will come from this part. YDSE, interference or superposition. 1 or 2% question may come from the other parts, polarization, diffraction, and so on. So we will try to cover them up in the next class. I hope you have understood what we have covered in today's class. Yes or no?
Yes, sir.
And I'll take this forward in the next class. Take care and God bless you.
Thank you,
Bye
sir.
bye.